Let's do number 6 here. This one is a little bit tricky because, first of all, you read it, increasing the voltage across two plates of a capacitor will produce what effect on the capacitor? So the first thing you want to do is say that, okay, well, I know that the capacitance is a charge per voltage. So you're going to think, well, if I'm increasing the voltage, then that means that the capacitance is going to decrease, and you're going to pick D. But this one's a little bit trickier because that's not the correct answer. The reason is because if you're saying that, then you're assuming that the charge is staying the same. But it's not staying the same in this case. So basically what you know that is staying the same is the capacitance, because the capacitance is also defined as the permittivity of free space times the area of each plate divided by the distance between the two plates. So the capacitance depends on this geometric arrangement of these two plates here. So this is the distance and then the area of each one here. So it does not say anywhere that you're changing the area of the plates or that you're changing the distance between them. So you have to assume that, okay, I'm not changing any of this. That means the capacitance is not changing. So if the capacitance is staying put, then if you increase the potential difference, then you must also be increasing the charge, because that's the only way that this will stay the same, by increasing both the numerator and the denominator. And if you think about it, well, you know that you're going to have a certain potential difference between the two plates here when you have some positive charge here and some negative charge here. Well, if you're increasing the potential difference, but nothing else is changing here, then that means that you must have more charge. And that's what causes the bigger potential difference. This is at an even higher potential, this is at an even lower potential, because you have more charge here and the negative charge here, so it makes an even bigger potential difference between the plates, and that's what's happening in this problem. Number 7, two capacitors with CA greater than CB are connected in series. Which of the following is true? And it's going to be that there's the same charge on each capacitor, so this is the equation that we also talked about in class, that the charge is the same on each one. I'm not going to go through that whole process of explaining that, but that just comes from this equation, that in series, the charge is always the same on each capacitor and then on the equivalent capacitor. Answer D, that would be if they were connected in parallel, then the potential difference across all of them would be the same. Let's do number 8. So we have a 0.25 microfarad capacitor connected to a 400 volt battery. Find the charge on the capacitor. So this one is a plug and chug, where you have to know that the relationship between potential difference in charge and capacitance is C is Q divided by delta V. Capacitance is charge per potential difference. And then we're looking for charge, so charge will be C times delta V. And then the C is 25 times 10 to the negative 6 farads, and the potential difference is 400 volts. Multiply those two numbers, and you'll get 1 times 10 to the negative 4 coulombs.